Hello everyone, and in this lesson we are going to go through a review of area 6C, and I'm also going to have a look at a really useful problem which looks at pegs in holes. We're going to be going through what the meaning of square root units is and doing some conversions. Going to go through things that you've seen before, but we'll go through again areas of squares, rectangles, triangles, rhombus, and all these different shapes. Of course, you've got the formula sheet for those on page 6, so make sure that you refer to those when doing your questions. And I know that you've done those before, but so for the most part, you should find this okay. As you're going along with this, my advice is to pause occasionally if you want to have a little bit of think about how to do or try something yourself. Otherwise, I'm going to go through the examples for page 6, 7, 8, and then, of course, you'll be able to then have a go at these questions here. And we'll sort of have a period and a half to work through those questions. All right, so let's get started. So we're on page 6 of your notes, and what I'm going to do is actually start with a problem which looks at pegs in holes. The question is, I would usually do this on the whiteboard and get you to do this, but let's have a go at this. And this is good for practicing your algebra skills, and a little bit of Pythagoras theorem, areas of circles, squares, and a little bit of sort of ratios as well. So this is a good one. It incorporates quite a few different skills. All right, so the question is, what takes up the most area if I have a square peg in a round hole or a circular peg in a round hole? Now, the first thing, I guess, the hint in order to do this is I'm going to draw the center of this square. And, of course, if I get the center of this square and I go over to here, and it's also the center of the circle, by the way, then we're going to call that the radius. And, of course, that there would also be the radius. Okay, so what we're going to do is we're going to do this for the first one. Now, what I'd like to do, we basically want to work out what uses up the most area, what's more effective, a square peg in a round hole or a circular peg in a square hole. Well, on the left-hand side, I'm going to do this one, and on the right-hand side, I'm going to do that. Now, feel free to pause this if you want to have a go yourself. So first of all, pause now if you want to have a go. Otherwise, follow through with me now. Okay, so what we've got is, I think you've got to realise a square is both sides are equal. Now, I'm just going to, for argument's sake, I'm just going to call this side x and this side x. The one on the left is a little bit, there's a couple more steps involved. So if that's a square, then that's a right angle, which means I can draw myself a little triangle, a right angle triangle, and that's the same as we've got. This is x, and this is x, and of course the hypotenuse would be not r, it's 2r. Okay, so now we've got a relationship between that, because what we want to do is we want to find the area of the square, and then we want to find the area of the circle. Okay, so so the relationship is using Pythag. We've got the two shorter side lengths squared, x squared plus x squared is equal to, let's use brackets because 2r is squared. All right, so that's x squared plus x squared is 2x squared, and 2r squared is the same as 2r times 2r, which is going to be 4r squared. Now, dividing both sides by 2 is going to give us, x squared is equal to 2r squared. All right, now, and of course, we don't want to find, if I want to find the area of the square, then that's going to be the area of, So like length times width. But the length and the width are x. So that's x times x, which is x squared. And as you can see here, x squared, I've already found what x squared is. That's 2r squared. Okay, let's find the area of the circle. Well, that's nice and easy because the area of the circle is pi r squared. And we've already got, so we've just got in terms of the radius. Because radius could be anything. We're just generally looking for a perfect circle and a perfect square inside that perfect circle. All right, so now what we're going to do is, here's the hint. We want to work out what fraction of the square area is equal to that of the circle. So what we're going to do is we're going to do that area of the square. So let's do to work out what fraction it is, the area of the square is equal to, well, we've got it up here, is 2r squared. And the area of the circle is pi r squared. Now, what do you notice? That those r squareds are going to cancel. And in actual fact, we've got 2 over pi. Now, that's going to be a number. We know, though, that 2 is going to be less than pi because pi is around about 3.14. But if I was to do that in a calculator, so I'll do that just quickly, is 2 divided by pi. I'm going to get some decimal answer for that. So 2 divided by pi is 0.3637. Now, if we do that as a percentage, in other words, if I times that by 100, then that's going to be 63.7%. So what that means is that if I fit a perfect square inside a perfect circle, then this area here is going to be 63.7% of the total area of the circle. All right, so let's compare that with the other one. What do you think? Do you think that a square peg in a round hole is better than a circular peg in a square hole? Well, let's have a look. So now let's do the same thing, but this time this is a little bit easier because we've got, first of all, we've got, I won't do it that way. I might do it this way just to make it easier. So here's my center of my circle. There you go. There's my radius. And there's another radius down here. So the area of the square is equal to, well, this distance here is going to be 2r. Feel free to pause this if you like, because we're going to do exactly the same thing. We want to find the area of the square, we want to find the area of the circle, and then we want to find this the area of the smaller thing over the big thing. So let's find the area of the square is going to be length times width, but each of those is equal to 2r. So it's 2r times 2r, which of course is 4r squared. And once again, the area of the circle is just that. It's just pi r squared, which you've been doing since probably year 7 and 8. So now what we're going to do is let's find, over here we had the smaller shape. Well, this time the smaller shape is the circle. So let's do that. So we're going to do, this time it's going to be the area of the circle over the area of the square. Now feel free to pause this and to find this out and to work it out as a fraction. Okay, so as you can see, we've got the area of the circle is pi r squared, and the area of the square is 4r squared. And once again, those r squareds are going to cancel out. And that's going to be pi divided by 4, which we can just do in a calculator. Pi divided by 4. I'm just going to work that out now. Pi divided by 4. And that's going to be 0.785. Now, if we convert that to a percentage by timesing by 100, that's approximately 78.5%. So the question is, what's better? What uses up more area? A circular peg in a square hole or a square peg in a round hole? Well, as you can see, this one here is better because it utilizes, that circular peg utilizes 78.5%, where this a square peg in a round hole uses up 63.7%. So there's basically, if you like, there's about 20, close to 30, around about 36% of wasted space, if you like. Wasted space, where over here there's closer to 21.5% of wasted space. Anyway, I thought that, look, this is are we going to ask you to do this in a test, for example? No, probably not. We might get you to do something similar, but as you can see there, that's utilising a few skills that we've already seen. Okay, so just quickly, we're going to be going through a number of these problems. Everything you need is really here. A lot of this you've seen before. This conversion table can be useful, but of course we don't necessarily need to use it, but it would certainly pay to, once again. So, but this time, remember, when we're looking at square meters, we're looking in 2 dimensions, so it's different to converting length. Now, also, in particular, before we're looking at perimeters of circles, this time we're looking at areas. So we're using the area of a circle, pi r squared, and we're using the fraction of a circle, theta is the fraction of a circle out of 360, because of course a full circle is 360. If you had a full circle, you wouldn't go ahead and use this, because it would just be 360 divided by 360 times pi r squared, which of course is that's just the area of a circle, isn't it? That's just going to be 1. Okay, so hopefully nothing's too foreign there. And let's put some of this into practice. All right, so we're going to be doing some converting units, and I'm going to take you through without the conversion table. Let's actually make one, and let's have a look at finding areas of various shapes, and then finally doing some compound areas, like so. All right, now first of all, let's have a look at this example. Let me do some. So in your exercises, you're going to need to do some basic conversions. But before we do that, before we just go, now in the past, when we go have centimeters and millimeters, usually we know that there's 10 millimeters is equal to 1 centimeter. But be careful, because we're converting square units here. So if we've got doing square units, then it's different. We're not just simply multiplying by 10 or adding 10 or dividing by 10 when we go this way, okay? Because let's draw a 1 centimeter squared. Now 1 centimeter, of course, is, if I have 1 centimeter, that's 1 centimeter, and this is actually 1 squared centimeter. If this area here is 1 centimeter squared, okay, because of course the area would be equal to 1 times 1, which is 1 centimeter squared. But what we've got to do then is, well, if we're doing the conversion to millimeters, then we need to, yes, we can use that table, but let's be a little bit more, use logic to be able to work out what that 1 centimeter is in millimeters squared. So 1 centimeter is 10 millimeters, okay? And of course, 1 centimeter is 10 millimeters. So if I was to do that multiplication, if I was to do 10 millimeters and 10 millimeters, then that is going to be 10 times 10 is 100 millimeters squared. So what that means is that 100 millimeters squared. So what that means is that 100 millimeters squared is actually equal to 1 centimeter squared. And if, as you can see, if we go up into this conversion table, if I want to go from millimeters squared or centimeters squared to millimeters squared, it says here we times it by 10 squared. That's because area is in 2 dimensions. So 10 squared, though, is 10 times 10, which is equal to 100. So if we go that way, we have to multiply by 100. If we go this way, we have to divide by 100. Okay, so that's how we use that. But let's go ahead. So now that we know that there are 100 millimeters squared in 1 centimeter squared, then what we can say is that so 2.5 centimeters squared is equal to 2.5 times 100 millimeters squared. So 2.5 times 100 is 250, or we can just move the decimal place across 1, 2. Add a 0, and that's where your decimal place is. So 250 millimeters squared. All right, so let's do the other one, but this time let's do centimeters squared to kilometers squared. So this is going to be a big one. First of all, let's do a kilometer. Okay, so this is 1 kilometer, and this is 1 kilometer. Okay, so we know that square area would be 1 kilometer squared. 1 times 1 is 1. But this time, let's change this to centimeters. Well, first of all, let's think about it. How many centimeters in a meter? Well, there's 100. Okay, so there's 100 centimeters in a meter, and then there's 1,000 meters in a kilometer. So we then have to times that by 100,000. All right, so 100,000 centimeters would be equal to a kilometer, and the same thing over here. This one's a little bit harder because, of course, it's not just going across from one to the next. If you think about it, we've got centimeters, then we've got, after centimeters, we've got meters, and then we've then got kilometers. Okay, so 100,000 centimeters and 100,000 centimeters. We want to get 2 kilometers squared. Now, what we're going to do is, if you think about it, is let's do this 100,000. Oh, geez, that's 100,000 times 100,000. We could do a little bit of scientific notation if you like. That 100,000 is the same as 10 to the power of 5 centimeters, if you like. And over here, that's 10 to the power of 5 centimeters. And as you can see, if I multiply those together, you might recall in your index laws, 10 to the power of 5 times 10 to the power of 5 is, we're adding these two powers, that's 10 to the power of 10. It's a big number. Okay, so this one's probably a little bit, but as you can see, if we want to change centimeters squared to kilometers squared, then what we have to do, basically, is we need to divide by 10 to the power of 10. It's getting a lot smaller. Now, let's have a look back up at a conversion table. Okay, let's have a look at this. So I want to go from centimeters squared, and I want to. So what we've done is we can divide by 100 squared, which, by the way, is the same as 10 to the power of 4. 10 to the power of 4, and then we can divide by 1,000 squared. Well, 1,000 is 10 to the power of 3, and 10 to the power of 3 to the power of 2 is 10 to the power of 6. So you can see there, that's where that 10 to the power of 10 comes from. Okay, so with this one, it might be better to actually do it in stages. And of course, you've got your calculator. I'm doing this without a calculator, and so this one can be a bit tricky. So what we're going to do is, all right, we're going to divide by 10 to the power of 10, or you can do it in 2 lots. So I've got we've got 6 zeros. So 6 zeros. Well, if I divide by 10 to the power of 10, if I divide by this, then you can see that we've got to go back 10 decimal places. So let's go ahead and do that. All right, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's fill that in with zeros, and that's where the new decimal place goes. So what we can say is that 2 million centimeters squared is actually 0.002 kilometers squared. That was a bit of a tricky one. So I would suggest too, when it comes to something like this, when you've got to go to centimeters squared, to meters squared, to kilometers squared, it's not as simple as just working out in one dimension. We're looking at area. Okay, so you might want to do 2 million, and then you might want to go from centimeters squared to meters squared, which is basically we divide by 100 squared. Okay, and dividing by 100 squared would basically say that 2 million centimeters squared is the same as going back 1, 2, 3, 4. That's 200 meters squared, and then once again you then need to divide by, I think it was 1,000 squared. It's 1,000 meters in a kilometer. Okay, and that's what gives you this result. Okay, so look, for the most part, some of these going one way is a lot easier, but some of these conversions, especially like this one, can be a little bit tricky. But you'll get a chance to practice these, and you will need to practice those. All right. So look, area of square area and converting can be a lot more tricky than doing just your length conversions. All right. Now we've just got some shapes, and of course you need to have a look at page, I think it's 6, and you've got the different shapes. But first of all, what are these shapes? Well, this one, of course, is a trapezium. This is an area of a trapezium. You've all seen triangles. This is the area of a triangle. Note the area of a triangle is half times the base times the perpendicular height, which is the height here. So this height here is perpendicular, so we can use that, and this is the base. If this was the base, then we would need to know this distance here, the perpendicular height. And of course, we've done areas of circles as well. The area of a circle is pi r squared. All right, it's saying to 2 decimal places were necessary. So let's do the area of the trapezium. Well, if you can have a look up at your formulas, but that's going to be the A plus B times the perpendicular height. And of course, A and B are the 2 parallel sides, these 2. Okay, so let's just fill that in there. That's 2 plus 6 times 3. Let's work out what's inside the brackets first. It's a half times 8 times 3. 8 times 3 is 24. A half of that is 12. Now, it's not 12 meters. We're looking at area, so remember all the units. Please use units. It's 12 meters squared. Area of this triangle, well, it's half times the base, okay, and of course it's times the perpendicular height. So we've been given the perpendicular height here is 1.1. So that's a half times 1.1 times, in this case, it's 2.6. You're going to have lots of different looking triangles, so you've got to make sure that you're using the right perpendicular height. So we've got, let me just work that out. Okay, so hopefully you got 1 point. You should have a calculator doing this as we go, pausing on the way if you need to. That's 1.43. The unit is centimeters, and we're looking at square centimeters. All right, so basically for these shapes, these sort of whole shapes, we're just using the formula, aren't we? And I think most of us can feel pretty confident in doing that. All right, the area over here is pi, always with pi with a circle, times the radius squared, which is 3.91 squared. Let's do that, 3.91 squared. And and then we're multiplying. Don't forget to multiply by pi. And I've got correct 2 decimal places. I'm not going to write equal sign. I'm going to write equivalent sign because we're going to do rounding. It's 48.028, so we're going to round off 48.03. And this time we're looking at kilometres squared, or square kilometres. So hopefully you'll feel okay with these sort of shapes. There's other shapes. There's kites. There's parallelograms. Parallelogram is just a sort of a skewed rectangle. So you should be able to work your way through those. And in your book, I believe that is on page, the formulas are on page 446 of your book. And page 6 of the notes. All right, so now what we're going to do is have a look at some areas of, this time, we're going to do some areas of circles. Just quickly, what have I done wrong here? I hope that you noticed, because you can see there that the area of a circle, unlike where we're doing the circumference is pi times the diameter, or 2 pi r. But notice that with the area of the circle, it is not the diameter that we're using the radius. So I just wanted to point that out to you. Hopefully you picked that mistake up. But as you can see, well, I've used and I did it for a reason, because of course this is a very common thing. A lot of students use the diameter when they're given the diameter. So the radius, let's try again. The area is equal to pi r squared, which is a half of that diameter, half of 3.91 squared. So let's try that again. 0.5 times 3.91 is equal to 1.955. Okay, and then now let's multiply that by pi. I've got 12.007. So that's going to be 12.0, rounding that up to 1 kilometre squared. So I just wanted to make notice that this is a very common mistake that students make. You need to make sure that you are halving the diameter, and when you're finding the area, you have to use the radius. All right. So what we're going to do now is let's find. So this time it's nice and easy. You can do this. I'll get you to pause this video now and have a go at this one, please. I'd like you to find the area. Okay, so hopefully if you've had a go at this, we've got the area is pi r squared, but this time we haven't been given the diameter, so there's no tricks there. Okay, if we're given the diameter, we'd have to halve it, and that's pi times 5.1 squared. Okay, and that's going to be 5.1 squared, and then times that by pi. I've got 81.71, approximately 81.71, and you don't forget the units, it's centimetres squared. All right, so for the most part, those whole shapes should be okay with. But how do we go ahead and find this shape? Well, first of all, if I had a full circle, that whole full revolution would be a full 360 degrees. So what we want is the fraction of the circle. Just remember though, with these, we don't have to worry about this or anything like this. We're not doing perimeter anymore, we're doing area. So we just want to know what fraction of that circle that is. Okay, so basically what fraction of that circle. So the area is, and this is, you'll need to use that it's equal to theta over 360 times the area of a full circle, pi r squared. So this is the fraction. What fraction is it? We're going to do this as much as we can without using a calculator. We're going to need it. 260 out of 360 times pi times r squared. So let's fill that in. 4 squared is 16. All right, now I'm going to try and do a little bit of cancelling here. First of all, there's a number which goes into 26 and 36. Or 260 and 360. First of all, let's cancel out the zeros. That would make sense. So that number is 2. So 2 goes into 26 13 times, and 2 goes into 36 18 times. Now, can we simplify that? No, because 13 is a prime number. It means that there's no other factors. This is prime, so we just stop there. Okay, you know that you've simplified it when you have your prime, okay, as your numerator. So let's times that by pi times 4 squared, which is times 16. Okay, so we can do a little bit of simplifying even more now, because 16, let's do some cross multiplying, or simplifying, and you can see there, there's a number which I can divide that by 2. You can also divide that by 2, and that's going to give us, we've got 13 times pi, that's times 8 over 9 now. And as you can see, we could keep going if you like, but I think that's the main thing is that, you know, if you ever had to do this without a calculator, in exact form, it's probably as far as we can go. 10 times 8 is 80. That'd be 104 pi over 9. Now let's see what happens if we do this in a CAS calculator. Let's go and throw this in a CAS calculator. I'm going to put all of this in. Now, when doing that, first of all, use your fraction button. Okay, so we've got the fraction button. We want 260. Put 260 over 360. And then we're going to times that by pi. And we need to get used to this calculator, by the way. So, you know, doing this in this calculator as opposed to the green calculator, please, the scientific one, you're going to have to use this in VCE. Let's have a look. If I do that, look at that, 104.9. That's going to give the exact answer. Okay, and in all honesty, if I asked you for the exact answer, that's how I want you to leave it. This is the exact answer. All right, so that's the exact answer. There's nothing wrong with leaving it like that unless you're asked otherwise. So we've been asked to do it at 2 decimal places. So if I go to the calculator, I'm going to go to the calculator now, and I'm going to press Control and then Enter. And that's going to give me my decimal approximate, 36.302. So therefore, that is approximately equal to 36.30. Okay, now it's your turn. What I'd like you to do is this time we're going to have a look at composite shapes, and this time, well, we've got perimeter and area. I might, for the time being, just get you to worry about the area for the time being. We've done some perimeter questions already in exercise 6B. So pause it now. I'd like you to have a go at this. You know, see if you can do it in 2 minutes. All right, pause it now and have a go. All right, now what I'm going to do, first of all, I might just have it get a small, just go down one thickness, and let's try this now. Let's try a different color. Red's a bit confronting. All right, so first of all, we're going to have the area. So we want the area, and that's going to be, in layman's terms, that's the area of the rectangle. And you don't have to write this, of course. I'm just explaining to you. Plus, though, we've got, be careful, we've got a half of this circle. All right? A lot of students, they go ahead and they work out a full circle, and you can understand that this is a half of a circle, which is not so bad. Now, let's work out that radius. When we're finding area, remember, we want to use the radius, okay? So we want to use that radius. So that distance there is going to be a half of 14, which is 7 centimetres. So hopefully you've tried this. All right, now this is what I want a lot of you to understand. A lot of you will basically work it out, and you'll work out part of it here and over here, and then you'll do some more over there, and then you'll add them together. We'll get into the habit, please, of trying to do it in less lines. Okay? So what I want the area is the length times the width, which is the area of a rectangle, 14 times, so we want 14 times 17, and then we want to work out, be careful if you use brackets properly, a half of a circle. Now, what is the half of that circle? Well, that's pi times the radius squared, which is 7 squared. Okay, now I'm going to do this in, you know what, I'm going to change this to 2 decimal places. I want the exact value. We know that we can plug that into a calculator. Okay, let's make it exact. Why the hell not? Okay, so let's have a look at this. First of all, let's see if we can do this in a head. And then let's check what the calculator does when I put all of this in to the calculator. And you know, if you do it like this, you're less likely to make mistakes. You're not going to make as many rounding errors. You basically can, if you are going to do any rounding, you can do it at the end. All right, so let's first of all look at 14 times 17. Okay, so 14 times 17. Don't know what has happened there. Okay, so let's do 14 times 17. Well, if I add 10 times 17, we know that that's 170. Okay, bit of a problem there. Let's just pause. All right, let's try again. Computer issues. So we were saying 10 times 17 is equal to 170. And then I've got 4 17s left over. Well, 4 times 10 is 40, and 7 times 4 is 28. Bring those together. That is 68. So look, without even doing a calculator, if I add those together, then that's going to give me 238. Now, let's go ahead and work out what 7 squared is. Well, 7 squared is 49, and times pi, that doesn't go anywhere, 49 pi, and of course we're then dividing all that by 2. Now, it looks pretty ugly, but that's the exact answer. So if I was asking for the exact answer, let's have a look. If we go ahead and put that into calculator, 14 times 17. Let's do it exactly how we've done it. 14 times 17. And then we're going to go plus, and we're going to use a fractions button. Okay, we're dividing by 2, and we're timesing it by pi r squared, which is 7 squared times pi. Let's see what we get. Look at that. 238 plus 49 pi on 2. It's exactly what we've got. And yes, if we're asked to find what an exact value is, that's going to be our exact value. Sorry, our decimal approximate. So there you go. They've got, this is our exact value. Hopefully those, you won't have as bigger numbers to deal with as that, but it can be done. All right, now what I'd like you to do is, basically this is the last thing I'd get you to do. I'm going to get you to pause it here, and I'd like you to have a go at these. Be careful though, we've got 80 degrees here. Well, we don't want 80 degrees in a circle. 80 degrees has been cut out of a circle. And over here, think about it, we've got, with this area here, how would you go ahead and do this? I'd like you to pause this for, let's say, if you can pause this for, and put it on your clock, let's go see if you can do it in 4 minutes. At least have a go at it, or at least have a go at one of them. Okay, so I'm going to go through the solution of these just quickly, and this will sort of finish us up. All right, so we've got the area of the sector, and we've got a composite shape. So first of all, we've got area is equal to, the fraction of a circle is theta over 360 times pi r squared. Now, we want this fraction in here, and that's going to be, well, if I take away 80 from 360, we get 280 degrees. So we've got, that's 280 over 360. It says here write your answer as an exact and also as a decimal. Well, look, I'm going to do an exact once again and explain how to do this. Times pi times the radius squared. So let's get in the habit of doing it, setting out your work like this. All right, let's think about it. If I was to cancel out those zeros, we can do that. 28, 36. Let's divide by 2. Is there a number that goes into both? Well, I reckon if we divide by 4, that's probably going to be a nice one. So that's going to be 7 over 9. Well, 7's a prime number, so it's we can't really go any further. Oh, look at this one. This is going to be nice. 3 squared. Now, 3 squared, of course, is equal to 9. So, isn't this marvellous? Look at those 9s. They're going to cancel out because, of course, we're going across. We can do that. We can cross simplify. So those 9's going to cancel out. So the answer is just 7 pi. And, of course, if you're asked to do it also to 2 decimal places, you can do so. All right. Lastly, we're going to go through this one. Well, the area, we've got the area of a square, basically. And then we've got this area in here. Now, of course, what is that? Well, how do we find that area there? Well, in actual fact, if you like, the easiest way to do it, I think, is the area there. If I was to do it here, I've got a square. This is a square here. This thing is a square. So if I was to subtract the area of a quarter circle from the square, then I'm going to get that answer of that area. So we basically need to find the area of those two shapes. Well, first of all, we can do the easy part is this one here, isn't it? That is simple. That is just length times width, and it's a square. Let's use brackets though. 5 times 5. Now, how do we go ahead and find this one? Well, we might need to do it on the side here, and so let's work out. There's no problem doing it like this. So what we're going to do is we're going to find, we might call this area, I might call this area 1, and I might call this area 2. And we might say, that's quite nice as we can label it like this. Area 2, area 2 is equal to the area of this square over here. That area of that square, this square here, as you can see, that's also 5 times 5. But then I need to subtract away. If I subtract away this shaded area here, let me get my highlighter out. If I subtract this area away from the square, that's going to give me my area 2. So let's do that. Well, what is that? Well, first of all, what fraction of the circle is it? It's a quarter circle. So let's use that. It's a quarter circle, and let's do the area of a full circle. And that full circle would have a radius of that distance there is also equal to this distance there. So that's going to be pi times the radius squared, 5 squared. Okay, so that's 5 times 5 is 25. And we're going to do this in exact. So we've got 5 squared is 25. 25 times pi is 25 pi. And don't forget, that's all times a quarter or divided by 4. So nothing wrong with separating it when you've got a complex problem like this, but it's quite clear that you've made it clear this is the area, and what we're going to do now is we're going to insert that over here. Oh, and isn't this marvelous? Because we want the area of 2 is, well, we've got 25 is the area of this square, area of that square. Then we've got to add 25, and then we're going to take 25 pi on 4. And 25 plus 25 is just 50, and then we're just going to leave it, 25 pi on 4. That's my exact answer. Okay, and as you can see here, I want you to get used to doing these questions, and like if you've got these composite shapes, especially some of the trickier ones, if it's a nice easy one, you could probably just add them together. But there's nothing wrong with doing outlining what this area is over here, that's area 2, and actually doing it over here separately. All right. Now, based on this, what have we done so far? Well, basically, we've pretty much covered everything we can from 6C. So what I'd like to do now is any time you have left, jump back into the conversation. Let's start working on the questions from 6C. We can work our way and try them there, and of course, we're going to have a whole working lesson to do those. Anyway, that's about all for me. We're going to have a working lesson and a little bit of time left over. So away you go, give this a go, and we'll have a working lesson as well in our next lesson. Thanks, everyone.